Cyclical function models, the Singapore Flyer. Just a quick reminder, guys, that what you do today and tomorrow in the Edpuzzle videos with this packet, you're going to do a Canvas assignment on Wednesday and Thursday, so make sure you know what you're doing. If you need help, ask Mr. Fikes or see if somebody around you kind of gets what's going on, asking questions. All right. By the way, everything you're doing this week while I'm gone has to do with Ferris wheels. Yay, it's kind of fun, right? Sure. Okay, so we're looking at the Singapore Flyer, which, let's see here, opened in Singapore, obviously, in February 2008. So at the time of its opening, the giant Ferris wheel was the tallest in the world. The Singapore Flyer consists of an observation wheel with a diameter of 150 meters. That's important, okay? A diameter of 150 meters. Atop a boarding terminal, giving the structure an overall height of 165 meters. Okay, you should definitely stop right here and make a note that if the overall height was 165 meters and the diameter of the wheel was 150, okay, then that means that your boarding terminal must be how tall? 15 meters, okay? All right, let's keep going here. 28 air-conditioned capsules rotate on the outside of the wheel to provide unobstructed views of the city. The wheel rotates at a constant rate of 26 centimeters per second. This is slow enough that the wheel does not need to stop for loading and unloading unless there are special passenger needs. And remember, the like air little capsules are where people sit. They have these on the Texas Star at the State Fair, so you've probably been in one, although probably not air conditioned. All right, so it said to draw a diagram, and this kind of took me a little while, so I did not want you to have to watch me make this, which is why I'm just going to copy and paste. Okay, so here's my sketch, and you'll notice that my wheel is about 15 centimeters off the ground here. It's not centimeters, sorry, 15 meters off the ground. My height is all the way up to 165 in total. The center has to be 90. How do I know that? Okay, well, if the terminal is 15 meters tall, the diameter of the wheel is 150, then you should be able to figure out the radius on this thing is 75 meters, which means 15 plus 75 puts me right at 90. So 90 is the center of this wheel. Again, that's an important calculation that you be able to make, is where is the center of the wheel, or how high is the center of the wheel from the ground. Let's keep going. Based on the information given about how many minutes would it take for the Singapore Flyer to make one full revolution? Hint, start by finding the circumference. Let's just go ahead and do that. The circumference of this wheel is 2 pi r, and again, we know that r, we just talked about it, is 75. And I can just type this into my calculator. All right, so 2 pi r looks like this, second caret key 75. So my circumference is 471.24. All right, so we got the circumference. Now what we got to do is we got to figure out how long it takes the wheel in minutes to start from the bottom and go all the way around again, right? One full revolution. The key piece of information is that it travels at a constant rate of 26 centimeters per second. All right, 26 centimeters per second. So what we have to do is we have to convert some things. Well, first of all, our answer that we just got is in meters. And we were given centimeters, 26 centimeters per second. So let's change meters to centimeters. And all we got to do for that is multiply by 100, which you probably know. But this is what this looks like. Remember, when we're doing unit conversion, the whole idea is you want to be able to cancel off units. Like I want to be able to do that. I want to be able to cancel off meters. So I got to figure out how to do that. Well, if meters on the bottom, 1 meter has 100 centimeters, which is perfect, right? It leaves me with the one unit that I wanted. So all I got to do is multiply 471.24 by 100. I think we all know that is just 47124.0, or just 47124. And so now I have centimeters. Okay, so we're going to go ahead and use this to calculate the next part. What we can say is that 47124 centimeters is in one rotation. And so what I want is minutes. I want how many minutes is this going to take? So let's think about what we can do. Well, and here's the key. They told us how many centimeters per second, right? And I want centimeters on the bottom, so it cancels with the centimeter units over there. So they said 26 centimeters in 1 second. But now I can cross off centimeters, so I'm happy. And then we keep going. All right, I want to be able to cross off seconds, so it's going to go on the bottom of my next ratio. And keep in mind what you want. You want minutes. Well, I can say 60 seconds is in 1 minute. And I think that's all I needed, right? My seconds are crossing out, so now I'm left with minutes per rotation, which is perfect, right? That's what I wanted. Now remember, in fractions, you multiply straight across the top, which is going to give me 47,124 over 26 times 60, which, let's do hit in our calculator here. So 47,124 divided by the way, if you don't use parentheses right now, you're going to get it wrong because your calculator is going to do order of operations. All right, times 60. Again, make sure those parentheses are there. And we get 30.207. I'm just going to say about 30 minutes. So about 30 minutes per rotation. And we're going to use this calculation here in a minute. Okay, flip it over. These next two questions are probably the most difficult in the entire packet, so let's make sure that we're listening, okay? All right, what is the height of a capsule 1 minute after it leaves a loading platform? And it's talking about what is the height from the ground? You may have to recall some geometry skills to help you here, and you definitely will. Taylor should be the best at this. I had Taylor for geometry. Okay, let's keep going. Make sure your calculator is in degrees, all right? That's super important. So first things first, I'm going to go to my mode, and I am going to click on degrees to make sure that I don't get some crazy number here for my answer. All right, so the height of a capsule. Y'all, this requires two separate calculations, and we definitely have to understand both. If we want to know how far it is off the ground, we have to know how much did it travel. And remember, it's traveling in a circle. Okay, well, if it's traveling in a circle is 360 degrees. And it's going to take us about 30 minutes to make that whole circle. So 360 degrees divided by 30, again, you can probably do this math in your head, is going to give us 12. All right, so 12 degrees per minute. That's what that means. So my wheel is traveling at about 12 degrees per minute, so that in 30 minutes it goes the whole 360. All right, 12 degrees per minute. And remember, I only want 1 minute, so that's what I'm going to use for this problem. Now I'm going to draw a picture to help me with this math that's coming up. And you guys definitely should be drawing pictures. Also, don't judge my picture because it's going to suck. All right, here we go. Here's my circle. Here's the center of my Ferris wheel. So we got to start labeling some things here. The first thing we're going to say is we know that the loading platform is 15 meters off the ground. And we want to know, where is this little capsule after 1 minute? Well, we just figured out that the degrees it had turned is 12, right? 12 degrees. And we also know that that's a 75-meter radius. So all of this we should already know. You're just seeing it in the picture here. Something else to think about is, remember how we talked about how the center of the wheel was 90 meters off the ground? Well, yeah, because this is a radius too, and it's 75. And 75 plus 15 means that from the center to the ground, I've got 90 meters. All right, and I'm going to erase these couple of words, a couple of these things. I'm going to try anyway. All right, I'm going to leave that one. So we've got our picture right here that we have to work with. Now, you guys, we have to use some sine, cosine, tangent functions. We have to use some trig functions here, and it's been a while, so please listen. All right, I'm going to go ahead and I'm going to make a right triangle. I'm going to draw a line. I'm going to draw a line right here at the bottom. And this might look like it's exactly 15, but that's just because my drawing sucks, right? It's supposed to be a little higher, although not much higher than 15. So what we got to do is we got to figure out what is this length right here. Again, it's not 15. Okay, well, we know right triangles. We know sine, cosine, and tangent, or if we don't, we're going to get some practice right now. So let's take a quick look. I have the hypotenuse, and I have this angle right here. What I want to do is I want to go ahead and I'm going to find this distance. And the reason I'm going to find this distance is because I can do 90 minus this distance, and that will give me this length right here. Right? Think about it. If that's 90, then that is also 90, and I'm only looking for this piece of it. So once I find this distance x, I can go ahead and I can subtract to figure out the height from the ground. Here we go. We're going to use cosine. Why cosine? Well, because we have the hypotenuse, right, which is on the bottom. Cosine uses the hypotenuse, right? We know that's 75. And then here's my angle. My angle is 12. I'm using this side. This side is touching the angle I'm using. That's the adjacent side. So cosine uses adjacent side. Sine would have used this side, which we don't want right now. So cosine is adjacent, sine is opposite. So cosine. Let's go ahead and fill these numbers in. Cosine of 12 degrees is equal to the adjacent side, which I don't know, which I want to find. I'm calling it x, over the hypotenuse, which is 75. And again, it's 75 because it is a radius for the circle. It goes from the center to the edge. All right, well, this is just algebra. We're going to get rid of the 75 by multiplying both sides by 75. And so now I've got 75 times cosine of 12 is going to equal x. Okay, well, that's just a quick calculation in my calculator. Right, we got 75 times cosine of 12, and we get 73.4. All right, so 73.4 is x. So if I know, let's see if I can draw this. I'll use a different color. How about black? If I know that my whole center from the ground is 90 meters, and I just figured out from here to about here is 73.4, then I can subtract it to find my height from the ground. So take this number, 73.4, we get to do 90 minus 73.4. This is going to give me 16.6, which is my height after 1 minute. All right. Right, after 1 minute was 16.6 meters. All right, and it says I'm going to give you the information. I'm actually going to kind of help you build it. What I want you guys to do right now is I want you to try and find how high is it after 4 minutes. To help you get started, I'm going to give you a couple pieces of information. Remember, the first thing you need to do is remember that it's 12 degrees per minute. So 12 degrees times 4 minutes means the angle we're going to use this time in your triangle is going to be 48 degrees, not 12 degrees. I'll even help you draw your picture. It should look like this. Here's your circle, right? We know that it's 90 degrees from the center to the bottom of the ground. My angle here is going to be a little bit bigger. We know that your angle is 48 degrees. Okay, and so you're going to go ahead and you're going to figure out, okay, there's my right triangle. What is this length x? All right, what is this length x? And when you find it, you're going to do 90 minus x to get your answer. All right, hopefully you chose the correct answer. You should have gotten 39.82. 39.82. All right, I'm going to do the next one with you because it's just a tiny bit different. All right, so let's look at 8 minutes. And this is going to be the last example I do, and I will fill in the other ones for you, but I just have to show you that sometimes we don't subtract, sometimes we add. So take a quick look here. On the right side, I'm going to say, okay, 8 minutes. Well, 12 degrees times 8 minutes means that we're going to use the angle 96 degrees in our triangle. So here's my circle. Here's the center to the ground, like we've been working with. But this time, think about it. I want to do 96 degrees. So this would be like 90 degrees, and I even have to go a little bit further than that. So like this maybe? So here is my angle. Now, my right triangle has to look different than it has in the previous problems, right? I'm going to have to go from here down, all right? So I'm going to have to go from here down. Well, don't I already know that from the bottom of this triangle I just drew to here is 90 degrees? I should know that. Okay, well, sorry, I keep changing things. I know this is a hypotenuse still, so I know this is 75. If this whole degree was 96, well, I know that this piece on the bottom is a 90-degree angle, which means that inside my triangle is just 6 degrees. Okay, well then what piece of this triangle do I need this time? I need this side. And then I'm going to add it to 90 to get what I want. This means that the function that we're going to use is sine. I'm going to say sine of x. I'm going to remind you that that means opposite over hypotenuse. Okay, opposite over hypotenuse. And in this case, remember, this is our angle, and we're looking for the opposite side, not the adjacent side. This would be the adjacent side. Now we want the opposite side, which is why we are using sine. Okay, so we're going to say sine of 6 degrees is equal to the opposite, which I'm calling x, over the hypotenuse, which is 75. I'm going to find it the same way I did last time, so 75 times sine of 6 is going to give me x. And remember, that's because I multiplied both sides by 75. All right, let's use my calculator, see what I get. We're going to get 75 times, there's the sine button, sine of 6, and I get 7.8. All right, well, if this right here is 7.8, then my final answer is going to be 90 plus 7.8 to get 97.8 degrees. And that's going to go right here, 97.8 degrees. You guys go ahead and do 12 minutes in the video, in the ed puzzle. You get to draw your picture this time, get a little bit of practice here. All right, hopefully you finished and you found the correct answer. The correct answer for this one would have been 150.68. And then I'm just going to give you the rest. Okay, so 16 minutes is 163.36. I forgot to write down 20 minutes, so let's just skip it for a minute. 24 minutes is 66.82. 28 minutes is 21.48. And finally, at 30 minutes, we're at 15 meters off the ground. This one should definitely make sense because that means we're done with our rotation, so we should be back at the bottom, which is 15 meters off the ground because of the boarding terminal. All right. For the 20 degrees, we're just going to skip it because I forgot to write it down like I said. Sorry about that. Okay, so plot the data from your table on the graph below. Explain what the graph is showing. Be sure to explain what each axis represents and why you think the points fell the way they did. This is the last part we're going to do today. The rest of this is going to be tomorrow. So I want you guys to erase this. This was a typo. And we're going to say the bottom axis is time and the vertical axis is height. And I'm going to count by 50s. So I'm going to say this is 100, this is 50, this is 150, and the top is 200. All right, so what we're going to do is we're just going to plot our points here, and we're going to do the best we can, but it's not going to be spectacular. So let's see here. I need to go 30 minutes. So this is 15. This is 30. So I guess we'll say 20, 25, 10, 5. Okay, so 1 minute is really probably, let's see, less than 25. That's probably maybe about here. There's my height at 1 minute. My height at 4 minutes is going to be 39.82, so maybe right about here. 8 minutes is 97.8. Let's see, 8 minutes is 97.8, so that's right about here. 12 minutes is 150.68, which looks like maybe about here. 16 minutes is 163.36. 163.36. And remember, that's almost 165. That's almost to the very top of how high we should be going. So 16 minutes is about here. My next one, I skipped the data points. We're going to go back down to 24 minutes, which is 66.82. Which is probably about here. 28 minutes is 21.418 off the ground. So maybe 28 minutes is right here. And then 15 is way back down here. So I'm going to guess my data point was somewhere in there. All right, so we kind of see that it looks like this wave. All right, well, that makes sense, right? Because it's the capsules at first when it starts spinning are not getting that much higher off the ground. But then once they're on the sides of it, they do, right? They start to get a lot higher off the ground. So you guys in Ed Puzzle, choose what you think the best explanation is on the side.